Okay, well, happy Friday, happy February, and we'll pick up where we left off. So we left off talking about regular expressions, talking about character sets, and now we have character classes. And these are basically little shortcuts that we can use to. Let me turn down my volume here. Shortcuts that we can use for character sets. So again, the pattern I want you to notice is that the lowercase letter means match that thing. The capital of that letter is do not match that thing. So lowercase d is match any digit, and capital D is do not match a digit. W is word characters, which count all letters, numbers, and underscore characters. So think of creating a username on a website. Probably word characters are what is allowed, and then finally we have space characters. So let's take a look. These all count as different white space characters. We have form feed, which is a page break. So technically, so a lot of these are kind of carryovers from when people use typewriters, because people used to have typewriters and then they transitioned to computers, right? And so a lot of these ideas came from that. So form feed is like when you load a new sheet of paper into the typewriter, and so that corresponds to creating a page break and telling the computer to go to the next page. Line feed is going to a new line. And carriage return is returning the carriage to the front. So I don't know if you've seen movies or if you've ever used a real typewriter, but there's kind of this thing where you go chugga, 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 chugga. You're typing, and then and you see there's this roll. The way the typewriter works is the typewriter is only able to type letters in one position, and it moves the page across like this, right? And then you hit enter, and it rolls the page up, and then what you see is they go shh. So they type, and it goes ding, and then they hit enter, and then somebody takes their hand and goes right? So that when they hit enter and it rolls the page up a line, that's the line feed, and then when they take the carriage and push it all the way back to the right, so it starts at the beginning of the page, that's the carriage return. So those are actually two separate things, but basically every time you hit enter on your keyboard, you are entering new line and carriage return into the system. So that's what's happening. You also have tab, and then a vertical tab. I don't quite know what a vertical tab is, but anyway, that's what we have. But anyway, just to kind of capture all extra white space, so kind of like all of these new line, all of this spaces and non-breaking spaces. We don't have a separate character for spaces and non-breaking spaces here. Whatever, you can just do \s, okay, or in R, it's \s to kind of get all of these new line characters. Okay, so what do we have here? This is a character class. I've got P\D. This is to say P followed by a digit. So we are going to match just the P0N here. We're going to get false, 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 true for P0N, false for everything else. P\D is going to be P followed by a non-digit. So we're going to get a match on everything other than P0N. Okay, so all of these have a P, and they're all followed by something other than a digit, with the exception of P0N. Okay, P followed by a non-word character. What is this going to match? Maybe it's too early to ask. So the only one that's where we have P followed by a non-word character is going to be the P dot, and everything else, the letters, the numbers, well, I mean, that's basically all we have. Those are all word characters, so we're only going to match P dot N. Okay. We also have, these are also other character classes that you can have. These are known as Posix classes. These Posix is basically like a operating system, so Unix and Linux fall under Posix. Windows does not, so these may or may not work on a Windows machine, depending on how much stuff is implemented. But you can also use these, and so you have alnum for alphanumeric, alpha for any letters, digits, lowercase, uppercase, space. You also have punctuation, print, graph, hexadecimal digits, and then ASCII control characters. Again, these are just little shortcuts, and I guess shortcut is debatable because there's more characters in colon lower colon than to write little a through z, but these are what we call Posix classes here. Okay. So if you wanted to do these, so these ran just fine on my machine, which is a Windows machine, but these regular expressions may or may not work in the console, like if you open up like PowerShell. I'm not quite sure. But anyway, okay. So here I say match any letter, and this matches everything because there's letters, right? Has a digit. The only thing that has a digit is the P0N. And again, you can put in P and whatnot. Again, another weird thing about R, you kind of have to do the double square bracket here for the Posix classes. Again, this is just a quirk of R, not it's not a universal regular expression thing. But anyway, that's what we have here. Okay, we have these anchors. Anchors are to indicate either the start or the end of the string. Also word boundaries. So you can do caret for the start of the string and $ for the end of the string. You also have corresponding A and Z, A for the start and Z to the end, which also kind of remembers, but capital A, capital Z. We have B/B for word boundary and /B for not a word boundary. Word boundary is basically the edges of a word. So it's assuming like spaces separate out words. And so word boundary is basically the spot that is in between the letter and the space. So if you have hello there, you have a word boundary between the O and the, you have a word boundary at the start of the H. You have a word boundary between the O and the space. You have a word boundary between the space and the T for there, and then you have a word boundary at the very last E of the thing. So it's just kind of like if you had to trace out a letter, you've got, or trace out a word, where do you put those boundaries? That's at the word boundaries, okay? So let me just show you a quick example here. I have text, the quick brown fox jumps over the lazy dog. That's intentional, having two dogs there. And I'm gonna just say, hey, replace any time you see the pattern THE, THE, replace that with a dash. So what we're gonna get is dash quick brown fox jumps over dash lazy dog. This is just a literal match, no surprises there. Here I'm going to put in the anchor, and I'm going to say caret, meaning only at the start. So only replace, this has to be at the start of the line. If it has THE, replace that with a dash. And so that's going to replace the first instance of the, because this is start of the line THE, and this one is not start of the line THE, it's just THE. So no match here, but a match over here. This is the same thing. You can also do \A, and it is exactly equivalent to using the caret to say it's at the start of the line, and we have that. Okay. Here I have THE $, so this means match THE at the end of the line, and we're not going to find any kind of match because the end of the line ends with DOG, so there's no match there, so nothing gets replaced in this line. All right, here I have replaced DOG with dash, so we're going to get the quick brown fox jumps over the lazy dash, and that's a replacement there. Here I can say DOG $, that's only going to replace the DOG at the end of the line. So this DOG remains, but this one gets replaced. because we placed the anchor there, and that's what we have there. Okay. All right. What is this? What is this business going on here? Here I have word boundary. Okay, this is a capture group, but anyway, this is kind of one thing. I've got word boundary dot or dot word boundary. So what is going to be? So this is to kind of indicate a pattern, and then the vertical line is the or, and this is an alternate pattern. So it's word boundary, any character, word boundary. Replace that with a dash. So it's going to replace the W, because that's word boundary, W. It's going to replace the S, okay, that's word boundary. It's also going to replace the this space here. So let me just show you kind of what happens here. So we get words, jump, jumping, umpire, pump, umpteenth, and lumps, and it replaces the word boundary character, which is the W. The S is followed by a word boundary, so that also gets replaced. Here we have the space, which is basically, I guess, space and a word boundary, because there's a word boundary between S and the space and a word boundary between the space and the J. So that would technically match a word boundary space. And it just reads left to right, so it finds a match there, so it replaces the space with a dash. Then it's going to replace the J, because you got word boundary J, replaces P word boundary, replaces word boundary space, replaces word boundary J, and so this is what we get. Okay. This is going to be a non-word boundary, any character, non-word boundary. What is this going to replace? It has to be a character surrounded by a non-word boundary on both sides. It's going to replace the internal letters of each word. Okay. So you don't have a word boundary between W and O. You don't have a word boundary between D and S, and don't have a word boundary around the R's. So all of the internal letters of each word count as non-word boundary, any character, non-word boundary. Does it kind of make sense for what a word boundary is doing? Okay. All right, look at this. I've got replace little slash little b, so that's word boundary, UMP. UMP. So what are we going to have? This is basically looking for UMP at the beginning of the word. At the beginning of the word, we're going to replace word boundary UMP with a dash. So it's going to replace the UMP in umpire and the UMP in umpteenth, because that's going to be UMP at the beginning of a word, because we have it with word boundary. Here, if I do capital B, this says replace UMP as long as it's not at the beginning of the word, as long as it's not preceded by a word boundary. So this will replace the UMP in jump, jumping, pump, and lumps. Okay, so the jump, UMP and jump, jumping, pumps, and lumps get replaced with dashes. So these are word boundaries. What is this? UMP followed by word boundary is basically UMP at the end of a word. So that's going to be the UMP in jump, the UMP in lump, or pump. And I think those are the only two that will get replaced. Yeah, exactly. And then UMP followed by word boundary is going to be UMP as long as it's not at the end of the word. So it's going to replace the UMP in jumping, umpire, umpteenth, and lumps. Jumping, umpire, umpteenth, and lumps. All right. Okay, let me give you your first view quiz answer. The letter C. C as in cat. C as in cat. That's our first view quiz answer. So those are, hopefully that helps you make sense of word boundaries and non-word boundaries. Okay, here's a little quiz. What's the difference between caret, square bracket 09, square bracket caret 09, and 09 caret, sorry, square bracket 09 caret? What's the first pattern going to match? Yeah. So yeah, this has to be a digit at the beginning of the string. This is going to match what? Anything that's not a digit anywhere. And this is going to match any digit or the literal character anywhere in the string, right? So I got that all right now here. So this is an anchor string that matches a digit, matches a character that is not a digit, and this is matches a digit or the caret. All right, we have these quantifiers. Quantifiers are also very, very useful. So earlier I said, like, how would you do like 3 digits in a row? And we said you can do square bracket 0 through 9, square bracket 0 through 9, square bracket 0 through 9, and that would be 3 digits in a row. You could now that we have character classes, we could also do \d, \d, and that's going to give you 3 digits in a row. Now we have quantifiers. And we could just do \d curly brace 3. And that's going to say I want 3 of whatever thing I'm talking about. So, so this can be applied to literal characters or character classes or other kinds of groups to kind of match repeating. We have stars for 0 or more. This is greedy. We have plus to match 1 or more, also is greedy. Question mark, 0 or 1, and I guess we could also say this is greedy in that if it can match 1, it's going to match 1. We can say match exactly 3, match exactly 3 or more. All of these things are technically greedy, and match 3, 4, or 5. You can specify some kind of range, and I'll explain what this concept of greedy is in a moment. But let's just start off with just some basic quantifier examples here. So here I'm going to say replace any white space with a dash. And I think this is going to be very straightforward. We're going to just replace all the white space with a dash. Okay. This is anything but white space. Okay. And we're going to replace anything but white space with a dash. So basically, everything that's not white space, which are the letters and digits and punctuation, gets replaced with a dash. Okay. Here I say non-white space, 1 or more. So it reads left to right and is greedy. And so here, WORDS all counts as non-white space, 1 or more. So this entire thing, WORDS, is going to get replaced with a dash. The white space is left. The O matches non-white space, and we have 2 of them in a row. So that also matches non-white space, 1 or more. So the OR gets replaced with a dash entirely. This gets replaced with a dash entirely. This gets replaced with a dash entirely, the entire thing. So basically, all of these things where I have multiple dashes in a row will just get replaced with 1 dash. So I got 1, 2, 3, 4, 5, 6, 7, 8. I'm going to end up with 8 dashes. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So this is just 1 or more non-white space characters. Just gets replaced as such. What is the difference between this one and this one? So I said replace all non-white space characters. And here I'm going to say replace 1 or more word characters. So WORDS, these are all word characters. That will get replaced with a single dash. OR is all word characters. So is there going to be any difference between this one and this one? Yeah. The comma. So we're going to get a dash for the 9, and then it no longer matches. Once it hits the comma, that no longer matches. So the comma is not going to get touched, but the 876 will get replaced. Everything else is a word character as well. So the only thing that's not a word character are the spaces and the commas, so those remain untouched. So here we get dash, dash, dash. The 9, comma, 876 gets replaced with dash, comma, dash, and then the rest are also spaces and dashes. That's the only kind of distinction there. Okay, here I say replace any digit with a dash, and so we get the exact same thing. All the digits get replaced with dashes. Okay, here replace any non-digit with a dash. So that includes spaces and punctuation and everything. So all we're going to be left with are the digits themselves. So this is going to be dash everything, 9876, 123, 1234. Okay, so everything that's not a digit. All right, what's going to happen here? Dash plus. It's going to look very similar to this, except where you see multiple dashes in a row, that's going to get replaced with just a single dash. One or more non-digits, it's going to look just like this, except where you see multiple digits in a row, they get replaced with a single dash. So we get this. All right. This almost looks like a phone number. All right. Here, I say replace 3 digits, 3 adjacent digits. I need digit, 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 exactly 3. It reads left to right. So as it goes, we're going to replace, when it sees a pattern of exactly 3 digits in a row, it's going to replace it with a dash. So we're going to get year, the 199 gets replaced with a dash, and the 6 gets left over, because once it matches 199, that counts as a match, it replaces that, and it keeps reading, and then it sees a 6 and a space. So that doesn't match the pattern of 3 digits in a row. Keeps going, we got 310 that gets replaced, the 123 gets replaced. Similarly, 1, 2, 3, 4. The 1, 2, 3 there gets replaced with a dash. The 4 is a single digit, but we need 3 of them, so it doesn't match the pattern. 5 by itself also doesn't match the pattern. Here we say replace anything from 2 to 4 digits. And so 1996 gets matched entirely. That's 4 digits in a row that will get replaced with a dash. 310, 123, 1234, these match the pattern entirely as they match 2 to 4. The single digit 5 all by itself will not match the pattern, so that will remain. And so we get dashes replaced for those things. Okay, here's another example. Here I've got the question mark. Question mark means 0 or 1. And let's see if we can understand what we have here. So here I've got a vector. I've got mama, 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 mommy, mom, and mother. Okay, so these are different spelling variants of, I guess, how someone might call their mother. Okay, and here I'm going to say string match, and we want to start with a capital M, an A or an O, followed by a lowercase m, and we want 1 or 2 of those. So that would match the capital M, the O and mama, the 2 M's here, and then this is followed by an A or a Y. Okay, so we're going to get A, we'll get M, capital M, A, lowercase m, 1 of them, lowercase a. Okay, capital M, A, lowercase m, A. So here this is telling us what the string match says, match what we have in the pattern, and I get mama, 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 mommy. The mom doesn't match, because here we're saying we need a capital M followed by an A or an O, so that matches the O, followed by 1 or 2 M's, lowercase m's, and that does match. But here we are demanding an AY. Okay? We are saying it needs to be followed by either an A or a Y. And so therefore mom does not match. Okay? If we want to match mom here, then we could put a question mark after this thing, and that makes it optional. Okay? So the question marks matches 0 or 1. So in this case, we're going to match mom here, because we get capital M followed by an A or an O, in this case an O, followed by a lowercase m, 1 or 2 of them, and we have that. And we're saying, you know what? A or Y question mark means that's optional. If you have an A, go ahead and match it. If you have a Y, go ahead and match that. If you don't, that's also okay, and that's going to count as a match. Okay, mother is not going to match because we have no nothing to accommodate THEs or R's there. All right. All right. So does that kind of work for how the question mark goes? Yeah. All right. We have greedy and we have ungreedy matching. Okay. Greedy means when you have a quantifier, it is going to try to match the most letters that it can. So when you say, hey, I need you to match one or more, if it can match more, it's going to try to match as much as it can. So here I say the text is going to be Peter Piper picked a peck of pickled peppers. I was like, what is a peck? Anybody know what a peck is? A peck is equivalent to 2 gallons. It's an actual measurement. It's equivalent to 2 gallons. So Peter Piper picked a peck of pickled peppers. And here I'm saying extract capital P, wildcard, so any character other than a new line, 1 or more, or 0 or more, star is 0 or more wildcard characters. And the last character, though, to end the pattern is an R. And so what this is going to match, it's going to match all the way up from the first capital P. The dot star will match the rest of all of these letters until it reaches the R here. And so, so this is greedy, and it's going to do Peter Piper picked a peck of pickled pepper. And that's the entire match. I can put in the question mark to the quantifier, and this makes it ungreedy. And so this is going to find the shortest, the smallest match that matches the pattern. So what will this match? Capital P dot star question R. Yeah. This will match only Peter. So this is the smallest match that qualifies, that matches this thing. And the question mark makes it ungreedy. So it's going to try to find the smallest pattern here. Okay, so here I can say, I can do string extract all. And so this will match Peter and Piper. Okay, because capital P dot star question R will do Peter and Piper. Here I can do capital or lowercase p. And what are we going to get? Again, this thing reads left to right. Left to right. So it's going to start by matching the capital P in Peter, reaches the R. It's going to match the capital P in Piper. It reads left to right. So it's going to keep going, and then it finds the R here. And then it's going to find this lowercase p here and go all the way up to Pepper. So we're going to get Peter, Piper, and then starting, again, it reads left to right. We're going to go picked a peck of pickled pepper. Peter, Piper, and picked a peck of pickled pepper. You might say like, oh, well, I could have made it even smaller by just matching the PER here, okay? But regular expressions read left to right. So that's, so it starts off by saying, hey, can I match the first part of this thing? And it matches the first part of the thing. And then it keeps kind of saying, all right, well, you're looking for dot star anything, dot star, and it keeps going, ending with an R. So regular expressions read left to right. All right, let me give you your second view quiz answer. It's the letter B. B as in bear is our second view quiz answer. Okay, we have parentheses, and these group different parts of our regular expression together, and they can also create capturing groups. So capturing group will match basically any part of the pattern defined by the parentheses, and you can then reference them later, or you can extract, match those out separately. You can also put in a question colon inside the parentheses, and that becomes a non-capture group. So let me just show you examples, and you use capture groups with string match or string match all. So this would be this is the literal ABCD. It's got to match the text ABCD, but what's inside the parentheses will be a capture group. All right, here this matches the pattern ABC exactly, but it's a non-capture group. Here I have A, B, C, D, E, F, G, H, I. It's going to match that first, and it's going to extract out A, B, C as a capture group and G, H, I as a capture group. Here you can also use groups to kind of have OR statements in there. So you can have MRS, MS, or MR, and preference for the matches are given in the order provided in this grouping statement. So it's first going to try to match MRS. If it can't, it's going to try to match MS, and if it can't, it's going to try to match MR. And then if you want to back reference a matched group, you can use a \1 or \2. Again, in R, you got to do double \1 and whatnot. Okay, so let's just try out a simple example. So I have B, C, D, E, F, G, H, I. G, H, I is in a non-capture group. B, C, and D, E, F are capture groups. And so when you do string match all, it's going to search for this pattern. It finds it. This is the it extracts out the entire pattern that does match, the B, C, D, E, F, G, H, I, and then the capture groups get extracted. So it pulls out the B, C, it pulls out the D, E, F. Okay. Here, if you have this A, B, C, D, E, F, G, H, capital I, and you try this, it's not going to match. No match here because it doesn't match this pattern at all. It's looking for B, C, D, E, F, G, H, lowercase I, no match. So no match and no match. No capture groups get pulled out. All right, so here I have Mr.Smith, Mrs.Lee, Ms.Garcia, and we're saying we're going to search for MRS or MS or MR, one of those things. So it says, okay, this is what this is the pattern, and then we're going to extract out, because it's in a capture group, we get out the MR, the MRS, and the MS. All right, MR, MRS, and MS. If, remember, with the capture group, and you have these ORs, it tries to find a match in the order that they're provided. So here, if I do MR or MRS or MS, this is gonna return the wrong results, because what's gonna happen, okay? So MR.Smith matches MR, but then when it comes to Mrs. Lee here, MR matches right here, and it says, that's a match, and it extracts that, okay? And then it keeps going, and it says, okay, can I match MR? Nope. Can I match MRS? Nope. But I can match MS, and so it pulls that out, okay? So in this case, because MR is like a smaller, is like a substring of MRS, in this case, as soon as it encounters the MR here, it's going to say, I found a match, and it pulls that out, okay? But again, preference is given in the order given. So here, if you want to say MRS or MS or MR, here it's going to first try to find a match for MRS. It doesn't. Then it tries MS, and then it doesn't, and then it finds MR, and that's a match, so it pulls that out. And here again, it first tries to look for MRS, and it finds a match for MRS, and so that pulls out. Okay. So when you establish some kind of capture group with alternation here, with the vertical bars for OR, you do have to take care in the order that they are presented, because it's not going to necessarily work here. Okay, so this is how it could be kind of made even more useful with a capture group here. Oh, here's a kind of a short pattern. We could do M, R question mark, and S question mark. And this will also, again, these are greedy. So if it can match the R, it's going to do it. If it can match the S, it's going to do it. So we can get the MR, the MRS, and the MS. There's going to be one pattern here that it will match that this doesn't match. And can you guys figure that one out? What is this going to match that we might not want to match? Yeah. Capital M all by itself. Yeah, capital M all by itself, it's going to match that as well. Which, I don't know, maybe, I guess if, yeah. So if we had like, I don't know, something there here. Okay, so what is this going to do? Here I got Mr. Smith, Mrs. Lee, Ms. Garcia, Andy Hope here. And here I'm saying match MRS, MS, MR, followed by a literal dot, followed by a space, and then I've got one or more word characters, so \W plus, and I have that as a capture group. So it's going to try to match this thing, and if it matches that, it's going to extract out our capture groups, which are identified in parentheses. I got two capture groups. So when I say string match all, it's going to say, okay, I found a match. MR dot space Smith, MRS dot space LEE, MS dot space GARCIA. These are the matches to the entire pattern. Here we established two capture groups. This is a capture group, the title, MR, MRS, MS. And then these letters, one or more word characters, also form a capture group. So we can get out Smith, Lee, and Garcia. So this is kind of like handy if you say, hey, I've got a list of kind of, I don't know, names addressed here, and I just want to extract out the last names, right? Mr. Smith, Mrs. Lee, Ms. Garcia. We just want to extract out the last names. You can do that. You establish the pattern where you're looking for the title. We're not looking for Andy Hope because we're in our pattern, we're saying we want it started off with Mr., Mrs., or Ms. There. Okay, and so we have that, and we're getting the last names as we pull them out here. Okay, so this is pretty much the exact same pattern. This says this is a non-capture group. Okay, so same thing as before. It's going to match the same thing, but here we're saying I don't need to extract out the title. Okay, I don't need to extract out the title. We're going to still match MR dot space SMITH. We're going to match Mr. Smith, Mrs. Lee, Ms. Garcia as the pattern. The only part that I'm interested in capturing here, though, is Smith, Lee, and Garcia. Just the extra word characters, one or more word characters. But we're not going to bother with the title here, which we've declared as a non-capture group. Okay, back references. So with this, we could say string match all, and I could say one or more word characters, followed by a space, followed by one or more word characters, followed by a comma and a question mark, so meaning optional comma. I got George Washington, John Adams, Thomas Jefferson, and when I match this, we're going to basically match name, comma, so we're going to get George Washington, and we extract out George and Washington, John Adams, and Thomas and Jefferson. Okay, so why would I want to do this? So what if I wanted to kind of do a replacement? I can, and I could say replace George Washington, John Adams, and Thomas Jefferson. What if I wanted to list them off as last name, comma, first name, right? So I'm going to say replace the second. So we have back references to each of our capture groups. This is going to be reference 1. This is going to be reference 2. So I could say I want reference 2, replace that pattern with reference 2, comma, space, reference 1, semicolon. So what we're going to get is we're going to replace George Washington, comma, John Adams, comma, Thomas Jefferson with Washington, comma, George, semicolon, Adams, comma, John, semicolon, Jefferson, comma, Thomas. We get the second capture group, which is the last name, comma, space, first capture group, which is the first name, followed by a semicolon. And this is going to be our replacement text. So that's kind of neat, right? A practical use case. Let's see if we can start understanding what these patterns are, right? So regular expressions are so great, but when you're starting to work with them, there's like so many things. Let's see if we could make sense of this pattern here. The pattern says we want a word boundary followed by a capture group of one or more word characters, followed by one or more spaces, followed by a back reference to that for earlier capture group, followed by a word boundary. So what is that going to do? It's going to look for, if you have a capture group followed by a space, it wants to find that same capture group again. Basically, it's looking for any kind of repeated words here. So I've got the quick brown fox jumps over the lazy dog. What it's going to match is it's going to find any instance where you have a word, okay, followed by a space, followed by that same word again. So basically duplicated words. It's going to look for duplicated words. And so here it's going to say the, and the word, which is in a capture group, that word that got duplicated is the. Here's a regular expression that kind of matches telephone numbers as we have them written in the United States. Okay. So let's try to parse through this. First, we have literal opening parentheses, question mark, optional. So we have an optional literal opening parentheses. Okay. Now we have a capture group consisting of a digit that starts with 2 through 9. So in the US, all area codes, none of the area codes start with a 0 or 1. So any area code that you have, any phone number you have, the first digit has to be not a 0 or 1. So something 2 through 9, followed by 2 additional digits. Okay, that's going to be our capture group. That's going to be our area code. Followed by a closing parentheses, which is optional. Then we have a followed by a dash, a space, or a dot, which is optional. Followed by a capture group. This capture group is going to be starts with 2 through 9. So after the area code, the first digit of the rest of the phone number also cannot start with a 0 or a 1. So 2 through 9, followed by two more digits, an optional dash, space, or dot, and then 4 more digits of any character, right? And that's going to be our last capture group. So I've tried to parse this out here, and we can say, all right, let's try running through this bit of text. We've got Apple, 1-800-786-1000, 31 parentheses 310 space 209-162, 310.208.0448. This 310 work, this and this and this, and it matches these things. With string extract, here somebody entered 2 phone numbers into their text field, and so it's just going to match the first instance. Okay, this second one it doesn't match. All right, this one is not a match. Doesn't count as a phone number because it starts off with the number 1. And so these are the matches that it gets. Okay. If I did string extract all, okay, with string extract all, we basically get the same thing, all right, except in this case where we have both the work and the home phone number, both of those get matched. Both of those get matched because in string extract all, it's going to go through and try to find all the matches within each text string here. So it matches the work phone number and the home phone number, which is listed there. And then where it didn't find a match, it just puts in a character vector length 0. Okay, we might do something and we might say, okay, you know what? Let's take these, let's just do string match, okay? We have these different things. Let's try to do some cleaning up, right? Because the formats are coming in a little bit different. Can I separate out the area code and the rest of the phone number? Yes, I can. Okay. And then, and again, I can do it similarly with string match all, and we would get both the work and the home phone number here. We might want to take this, do something workable. So here I say, hey, get rid of anything. We're going to do string match all, and then so with these results, we go through, and we want to turn this into something workable. So with string match all, I say, hey, go through everything in that list and just kind of bind it to a matrix. And then, and now that I have that, I can say, all right, take this third column, which is not in the same format, right? Some people put spaces. You know, if your phone number is, 786-100, some people put the dashes, some people put dots, some people put nothing in there, some people put spaces in there. So how do we clean that up? We can say, hey, take that third column, All right, look for this. We're going to take three digits, an optional dash, space, or dot, followed by 4 digits, and just replace it with the first capture group dash second capture group, right? And so that's going to clean up all of these things into kind of something that's a little bit prettier. And so this is how you can kind of deal with text and try to clean them up. All right, let me give you your last view quiz answer. Last view quiz answer is the letter E. E as in elephant. E as in elephant. Okay, last few slides. Less critical, but these are also features of regular expression. You have what we call lookarounds. We have look aheads and look behinds, and what we have positive and negative look aheads and look behinds. Okay, so basically, you can try to make sure that a certain kind of character exists, or set of characters, or a certain pattern exists ahead or behind the match. See here I put a gray hat on my gray greyhound. And here we are saying match gray, but only if it is followed by, right? So this is a positive look ahead, okay? Only if it's followed by HOUND. And it says, oh yeah, I found the match, and the pattern that it's only looking at is for GREY. So 29 through 32. This is technically not part of the pattern, okay? So hound, this part, HOUND, is technically not part of the pattern. The only pattern is gray, but it's only going to match the gray that's followed by hound. So it only matches the gray here. Here, this is kind of the opposite. This is gray as long as it's not followed by hound. And so we get the gray for gray hat and the gray here. And that's the negative look ahead. And then you have the same kind of thing here with positive and negative look behinds. It's just kind of preceding the thing. So here we're going to say we don't want, I'm sorry, we're looking for digits, one or more digits, only if they are preceded with a dollar sign, right? So if you have this, I withdrew 100 $1 bills, 200 $5 bills, and 5 $20 bills. Let's say you are only interested in the denominations here. And so here we're saying we only want the 1, 5, or 20, only if it's preceded by the dollar sign. And so that's kind of how look aheads and look behinds work. And so you can kind of study all of these examples. But that's it. That's it for regular expressions. This is enough for you to do your homework now. You have to work with regular expressions in that managers column to try to extract out the manager's name and their wins and losses and things like that. And it's definitely doable. So good luck with that. Have a great weekend, and we'll see you next week.